Hello everyone, and welcome to this AWS Community Day talk about Standardise Data Scientist Development environment. This will be the agenda for today. I'm going to have an introduction, and I'm going to talk about the machine learning history, development history at Qred, what we built, and then I'm going to throw in some demos there. But first of all, who am I? My name is Mattias Svensson, and I work as a Cloud Ops engineer at Qred AB. I'm coming from a sports background where I played professional ice hockey before I went into tech. I've been approximately 4 to 5 years in the cloud now and 3 years as Qred. In the summers, I love to play golf and ski the fluffy powder snow during the winters. So who are we at Qred AB? We are a fintech company leading in credits for small and medium-sized businesses. We were founded 2015. And we are in 6 countries, so Sweden, Finland, Norway and Denmark in the Nordics, and Belgium and Netherlands in the Benelux. We have 3 products: loans, where we give out loans from €1,000 to €200,000 for our customers. But we also provide a credit card with an invoice service, and we have factoring service. We have been in Financial Times fastest growing companies in Europe for 4 years in a row, and we are the only Swedish company that has been made the list for 4 years in a row. So how do we use machine learning at Qred then? First of all, we are auto-approving 40% of our loans in the Swedish and the Finnish markets. No human has been in contact with the application. The fastest customer journey we had is someone applying for a loan until they have money on the bank account is less than 10 minutes. So how is that possible? Yeah, we have a team of 14 data scientists, and the team is still growing. We have 12 models in production today, where the QSA, or the credit scoring algorithm, is the main model. And that model is calculating the risk of someone not paying back the loans. So how has our machine learning development history been at Qred then? First of all, when you're a small and a startup company, you've been really focusing on delivering a machine learning model artifact itself to production. So that means we had kind of an individual approach of how we're creating those machine learning scripts. Same goes for how we train their models. So everything was also on our local machines where we store our data sets. So it could look a bit like this. We had one data scientist who had more of a modular approach, creating script for feature engineering, processing the data, amputation, and then evaluate the model that create a model artifact. But we had another data scientist who have scripts for feature engineering and made a training of the model and evaluating the model in the same step. Or we have a third one that processing the data, training the model, evaluating model, and create a model artifact. But we also had, like I mentioned, all the data from our data sources stored locally on our machine. We had a review step on the model artifact. We stored that into an S3 bucket, and we had the manual process to deploy to an ECS cluster. So this is our old process. Of course, there is benefits with this this way of working. So, for example, it's great for experimenting. I know you maybe know better than me that experimenting is a big part of the development cycle for machine learning. It was kind of easy to get started. You just need your laptop and you can start to code right away. But as the company grows and we become more and more developers into our teams, we also saw some challenges. So first of all, we had basically no standardization of how we were working with the scripts for creating our models. We have a lack of structure in the repositories and reusability, so every repository looked differently from each other. But it was not so easy to use someone else's work into yours. And it was hard to implement new features. For example, we had a new PDF report that we wanted to use. So we had to do a lot of adjustment to get it to running for all the models. Limited or even impossible to reproduce. So, for example, to retrain our model was a challenge, and also to debug with an older data set if we see that the model doesn't perform as we want to. Limited processing power, everything comes down to how much money you will spend on your MacBook. Data governance, yeah, we stored production data everywhere, so that's not good for auditing, for example. And we have no data history of what data was run and when. So what did we build then? First of all, what did we want to achieve? We wanted to have some kind of cloud-based solution. We want to standardize and create a Qred way. This is how we are working with when we are creating our machine learning models. We want it to be scalable, to be reusable, so that we don't have to reinvent the wheel all the time, and we can open up the model for a new market, for example. We want to have a centralized place where we store our data sets, not throw it around on laptops. But we still want to be able to experimenting and have fun and do all that creative stuff that's data modeling development. So we started to use Sagemaker, and this is the sales pitch from AWS. We also start to use Sagemaker Studios, and that's a cloud IDE that integrates good with the whole Sagemaker ecosystem, where you, for example, can give it GPU and processing power for your need. We start to use Sagemaker pipelines. That's a set of extraction that you can reproduce the creation of the model artifact itself. And we start to use Sagemaker projects. So what is Sagemaker projects then? This is also from the documentation, but we use it as a template or a boilerplate for creating new machine model projects. So how does that work then? First of all, we also start to use another AWS service, the service catalog. This is also from the documentation, but we use it as a template of the boilerplate to create all the necessary AWS resources that we want for this particular machine learning project. So if you can see the arrow on the top there, the Sagemaker project will execute the service catalog. It's called product, and that will create your AWS resources for you. So what does our service catalog contains then? First of all, we have a standardized GitHub repository using CodeStar. We have a model training pipeline where S3 bucket where we can get feedback on every single Sagemaker pipeline run. We have a Sagemaker module registry where we store our model artifacts in a versioned way. But CodeStar also injects some seed code, and seed code is basically the base structure of your repository template or boilerplate. So that contained a GitHub continuous delivery, continuous integration pipeline. I will demonstrate that a bit later. We also have the experimental folder where you do the majority of the work. You're creating those machine learning scripts, you iterate there, and then you put them into the scripts folder where the model training pipeline will pick these scripts up and create a Sagemaker pipeline from them. And then we have the orchestrator that I will also demonstrate that later. So this is how the GitHub repository looks like when CodeStar have created it for you. So this is how it works then. So first of all, this is Sagemaker Studios. Then we get into the projects tab here. And then we can click on create a new project. And there you can find the organization templates there. And that's the Sagemaker, the service catalog and Sagemaker projects that we have templates for. We pick one of them here. And we give it a unique name. So the unique name will be used to set on all the AWS resources from down here. We also give it some tags, and then we create the project. And when this project is in moving, so here is the project starts, then we can get into service catalog. And here in the service catalog, we can find the provision product in the end there, and that's it under change. It means it's deploying. So if we click into this product, we also can verify that we have all the AWS resources that we want. So the model registry, the Sagemaker repository, and the GitHub repository, they are all there. And this maps down to an AWS CloudFormation stack. So here is the CloudFormation stack, the second one there that we created from service catalog, and that has all the AWS resources that we want. So this is so all our data scientists just create their project, and then they can start to work on the model directly without thinking about all the other things. Yeah, we get into the GitHub organization, and here we have the repository that was created with CodeStar. And if we click into that, we then have the templates here, template folders and everything. So the data scientists can just start to work on the model instead of thinking of everything around it. And the Sagemaker project, yeah, it contains the standardized repository that you just saw. We have the continuous delivery pipeline that will also deploy a new AWS stack, and that's the orchestrator. And the orchestrator is a step function. And the first step is to fetch all the data from our data sources and store them into a S3 bucket for a historic versioning. And the next step is to trigger the service, the Sagemaker pipeline, with that data set that we just fetched. And that we start the Sagemaker pipeline itself that has all the scripts that we were creating in the experimenting folder, with processing the data, training the model, evaluating the model, and then that comes out a model artifact from it. And we had the model training S3 bucket where you can get feedback on every run. You can see all the scripts that was run in a historical way and what data set was used to run against this particular run. And if something goes wrong, yeah, we can get some feedback on the pipeline run in a CloudWatch logs. And that will be stored, and the artifact will be stored in the Sagemaker registry. So this is how the GitHub Actions flow works for the machine learning project. So you get into our GitHub Action. We have one of the first steps here in the pipeline. The deployment pipeline is to deploy the orchestrator stack, GitHub CloudFormation stack. So that we can see that one here as well. And when that one is done, is the next phase where we building the Sagemaker pipeline itself. So yeah, it's here and then it's coming. And here we are building the Sagemaker pipeline from those scripts that we created earlier on in the experimenting. So we put them all together, every single piece, so we can get a repeatable way of how we were creating our Sagemaker artifacts. So when that one is done, we can get back in to the Sagemaker studios. And here you can first of all see that we have a connection to the GitHub repository there. And then, so we can clone the repo into the Sagemaker Studios. Then we can click on the pipeline tab. And here is the pipeline that was created for us in the GitHub Actions. And if you want to, and then we can execute the pipeline itself that will run all the scripts to create our model artifact. And we also have a graphical interface where we can see what steps was run in this pipeline to produce the model. So how does our new process look like then? First of all, we are all in Sagemaker Studio. We're working on our scripts of producing the data, train the model, evaluating the model. We get our data sources into the Sagemaker Studios. We iterate until we feel like now it's production ready. Then we use GitHub Actions to build all the pieces together from the script that we worked on in the experimental folder, like processing the data, training the model, evaluating the model, and that will produce the model artifact. So we have a repeatable way of doing this. Then we store that in our module registry, where we have a review step, where you can compare different model versions to each other. So you can compare with graphs and other matrices. So you can compare the version 1 with version 2 and so on. And we still have a manual deployment to the ECS cluster, but that's going to be the next phase where we do it totally automated. So this is how the old process looked like, where we really were focusing on delivering the model artifact itself, and we were all our local machines. This is our new process, where we are in the cloud, and we are focusing on delivering the pipeline that will produce it instead of... So we know exactly how the model was created. So what impact did we get? Yeah, we get a lot of more standardization. We have now a Qred way. This is how we work with our machine learning models. We get reproducibility, where you can debug it with an older version of your data set. We have automated the retraining process. So we have a cron job every month that will re-trigger the pipeline, so we can see how the model performs over a longer period of time. We have the model comparison, the module registry, where you can compare different versions. We have the data governance, where we store it, where we have a centralized place where we store our data sets in the cloud. And we have a data history as well. But we can still experimenting and be creative and do all that fun stuff that is machine learning development. But yeah, of course, there is some challenges with this as well. So first of all, Sagemaker projects and service catalog, they are all from now and forward. So it means that if you create some new seed code, for example, you will not get it to the older version of the projects. Is only from when you create it and forward. Sagemaker itself, it's kind of vendor locking. The Sagemaker pipeline code is very specific for Sagemaker. You cannot use it somewhere else, and it means you're going to invest heavily in the ecosystem of Sagemaker as well. Sagemaker Studio, yeah, it's a cloud IDE, so yeah, it's a limited offline power. You need to have internet to be able to work on your model. It doesn't have any extra features, so if you use the GitHub Copilot, for example, you will not have that as well. You're going to have some GitHub personal access token, just from Sagemaker Studios to your GitHub organization, but also from CodeStar when you're creating that template repository. And it's not so easy to get it personalized, like create signed commits and so on. And last, yeah, but not least, yeah, it can get pricey if you don't have a plan for it. So, for example, close down all the Sagemaker studios that is not in use, all the kernels that close them down every day during the weekend. You can do that with a lifecycle configuration. And don't use the Sagemaker pipeline to get like feedback on every single line of code you write. It's more for production ready because you're going to pay it by the minute. And I think our pipeline is like 40 minutes or something like that. So it's more for production ready or retrain of your model. So, but with this said, we learned a lot during the way of how we worked and how we want to work. And we had a great experience implementing this, and it was a lot of fun. So if this sounds interesting, you can always get to our website. We are looking for a machine learning, machine learning team lead, for example. We're also going to plan to release the GitHub action part as open source. Yeah, that's what it is. Thank you very much. I hope you enjoyed as much as I did.